Okay, this is part 2 of Lab 2, Instrumentation Part 1. This part, you're going to take and determine the resistance value of this resistor. It's a 33K resistor. It has orange bands on it. Look it up using your color code card here and dial in the 3 orange colors. You would see that it's 33,000 ohms. And you can measure it with a meter, such as this. Hook up these leads here to the positive and negative poles here. Turn this to the voltage, the resistor setting, and it should come up with an omega there. And it'll take and read the resistance. You have to make this measurement with the resistor out of the circuit. So I'm going to remove it from this circuit here. And I'm going to plug it into my multimeter. And as I can see, it's going to take and read something like 32.89 kilo ohms. Now, in this lab, you are going to take and determine what this resistance is by making a number of voltage and current readings, and you're going to take and plot that in an I current versus voltage graph, and we call it the IV graph. And the slope of that is going to be 1 over the resistance. So once you find the slope, take the inverse of the slope, and you'll have the resistance value. So I've got these hooked up. I'm going to take and connect this voltmeter. This is the, let me just say that the positive pole of the DC current comes out here, goes through my resistor into the positive pole of the meter here, the ammeter. And then the negative side is connected to the negative pole. If this is the positive side, then the positive side of my voltmeter gets connected here, and I'm just going to push this in. And the negative side of it is connected to the negative side. Okay, I hope you can see a little bit of this. If I turn this on, this here is your adjustment for DC voltage. This is a current adjustment. It's a current limiting knob, and you should just turn this all the way clockwise to its maximum setting. Okay, this dial here indicates the voltage. If you press this thing in, it'll indicate the current. So I'm going to give this a little bit of voltage, and you can see by just giving a little bit, I'm starting to peg my meter here, and my voltmeter is hardly changing at all. And so if I were to take a quick reading, this is reading almost 100 microamps, and this is reading approximately 0.1 volts. 0.1 volt. If you divide the voltage by the amperage, you should get the resistance. But this is something like 0.1 divided by 100 times 10 to the minus 6 amps, or 10 to the minus 4. So dividing 10 to the minus 4 into 0.1 does not give you 33K, 33,000. And if I try to manipulate this even more, it just pegs a meter. And what this is telling us is that we're getting a bad result. And as it turns out, it's really because of this meter. It's a bad meter. And we're just going to replace this with our meter of choice, this multimeter. What it is a good meter has a high internal resistance, and this is called a student meter, and it's cheaply made, and it does not have a high internal resistance, and there is current flowing through the meter that shouldn't be, and we're losing part of our signal. not a very good explanation, but we'll go on with the experiment here. So we're going to use this meter and this current meter. And so if I turn this up and I'm going to get some reading, let's just turn this up to about 100. Remember, before we got some number like 0.1 at 100 microamps. And we turn this to volts DC. And it comes up in volts DC. If you want AC volts, you just push this mode button and you go to AC. But we're reading something like 2.2 volts here. And let's get back to about 100 microamps. We're reading somewhere like 3.2 volts at 100 microamps. Much different from before. So you're going to record these two numbers, change this setting. Let's say here I'm at 80. That's 2.6. So you're going to do this about 8-10 times. Make a nice graph. About 10 times to get a nice graph. And plot I versus B. The slope will be 1 over R. Solve for R. And you should get 33K for the resistance.